extension cord is plugged into the wall. 120 volts. Two 100-watt light bulbs are plugged in. How much current is going through the cord? How much through each bulb? So we've actually got two questions here going on. They're both asking us about current, but one is saying through each bulb, and one is saying through the extension cord. So give us some problem. We do have some information. We are told that it's plugged into the wall. That does tell us the voltage is 120 volts. Okay. Now, we want to think about this for a second. We've got some power plugged into a wall. We've got a light bulb. And we've got another light bulb. They are hooked up in parallel. Everything in household circuits is hooked up in parallel. And we have electricity going around through here and around through here. But we can see as it comes through this wire, it's feeding both the circuits. So we're going to have twice as much current in the extension cord as we do in the bulbs. So there's a few things we can do here. We do have 100-watt bulbs. That is a measurement of power. That is the power of one bulb. So the power of one bulb is 100 watts. The total power of both the bulbs then will be 200 watts. And there's a few ways we can choose to answer this question in order to solve for current, which is abbreviated I. What we can do is we can actually basically just take these numbers and plug them into what we need. If we want to know the current drawn by one bulb, we're just going to use this measurement of power. So the current going through one bulb is just going to be based on our standard formula, but using this power. So we know that P is equal to I times V. Or to put it in terms of I is equal to P over V. So the current through one bulb is going to be the same as the power taken by one bulb divided by the voltage. So the power of one bulb was 100 watts. We're going to divide that by 120 volts. These are both SI units. So our answer is also going to come out in SI units, or amps. And so you can do a little bit of mental math, or you can use your handy-dandy calculator and just do 100 divided by 120 and find that you don't get quite a nice number, but we can round out about 83 hundredths of an amp, 833 milliamps, something along those lines. If we want to know how much power then is going through the cord, we have two options. We can start the entire question right from scratch and say the total current is going to be equal to the total power divided by voltage, which is 200 divided by 120. Okay, and we can work it out that way. But it might make more sense just say, hey, my cord is powering two of these light bulbs. It's got the current of two of them. So I would personally just take this answer and double it. And our total current going through the extension cord then is going to be 1.6 repeating, or 1.67 amps, or 1,667 milliamps. And those are our answers.